We are here reviewing for the AP exam. This is a super common question that you're going to see. I have a bunch of different parts that you may see from this as well. We do have a graph of f in an integral defined function. Let's get started here. So let f be the continuous function defined on the closed interval from 0 to 5, which you can see that in the graph right there. The graph of f consists of two line segments in a quarter circle, and that is shown below. Let g be the function defined by g of x equals the integral from 2 to x of ft dt. First thing we're going to do here is we're going to find g of 0, then find g of 5, g prime of 4, g double prime of 4, or explain why it does not exist. So for the first one, g of 0, all we're going to do here is substitute in a 0 into my integral. Now, if you notice, 2 is the larger value. That's on the bottom. We can go ahead and flip that so it becomes from 0 to 2 and make that a negative in front of ft dt. Now, since this is a quarter circle area here is going to be 1/4 pi r squared. Our r right here is going to be 2. So this actually is an area of pi. It's below the x-axis, so we can read that as negative pi. So this is equal to negative below the x-axis, negative pi. So this is actually going to give me an answer of pi for g of 0. For g of 5. I'm going to substitute in a 5. So from 2 to 5 of ft dt. This is just really simple geometry here. We got a triangle going from 2 to 5, and we have a base of 3. We have a height of 2. So it's going to be 1/2 base times height. So we're going to get an answer of 3. Not a big deal. So g prime, before I even get to g prime before, g prime of x is equal to f of x. So if I want g prime of 4, I just need f of 4. Now, you might be asking yourself, hey, why is that just equal to f of x? We take the derivative of an integral defined function. That's the fundamental theorem of calculus, part 2. You're going to substitute the x into the t value and take the derivative of x, which is just 1. So that's why g prime of x is equal to f of x. So if I'm looking for g prime of 4, I'm just looking for f of 4, which is actually equal to 2. Now, if I'm looking for g double prime of 4, that's the same thing as f prime of 4. And if you notice f prime of 4, we cannot find that value because of the corner, so this does not exist because of a corner at x equals 4. All right. Next question we're going to have here, part B. Find all values of x in the open interval from 0 to 5, which g has an inflection point, and give a reason for your answer. So if g has an inflection point, that means we're looking at g double prime, which we know is f prime of x. Now, we cannot talk about f prime. We can only talk about f. Huge error that many people make is that they are talking about something that we don't have. We don't have an equation. We have a graph. We can only talk about the graph that is given to us, so we must explain this in terms of f. So point of inflection is when g double prime changes signs. So that's when f prime is going to change signs of slope. Where do we change signs of slope? It's going to happen here clearly at 4. That's the only time that's going to happen. So we have a point of inflection at x equals 4. You can say because f changes from increasing to decreasing, that's totally fine, or the slopes of f change from positive to negative, that's totally fine. I always say use relative extrema, because relative extrema, if you remember, only occurs when slope changes signs, and that way I don't have to worry about increasing, decreasing, all that stuff. So I'm just going to put because f has a relative extrema there. All right, let's move on. Same problem, part C here. Find the value at which of x at which g obtains the absolute minimum. So absolute minimum, that means that we're going to use candidate's test. So we need to make sure that g prime of x equals 0. If you remember, that's what f of x is. So when does f of x equal 0? That happens at x equals 2. So I have just 3 candidates here for my candidates test. So I just make a little table here. And then so I'm going to use negative 2, not negative 2, it's 0. I'm looking at the y's. This is going to be 0, x equals 0. And we're going to use x equals 2, and we're going to use x equals 5. Now here's the good news, is I already did some of this work up here, so I have g of 0, I have g of 5. So g of 0 is pi, g of 5 is 3, and I didn't do g of 2, but I can find g of 2 real quickly because the bounds are the same. This has no area, so this is equal to 0. So the minimum, the x value which we obtain the minimum is at 2. So min at x equals 2. Make sure you answer the question. This one's asking for values of x, not for values, so I'm going to answer it in such by giving them the x values. Next one, find the value of the limit of, wow, a lot going on here. It's a ratio of 3 f of x minus x all over x squared minus 4x plus 3. I'm thinking right off the bat we're going to use LHOP, but I do quickly want to plug in these values just to check, and I'll do that by separating the numerator and the denominator. So this is going to be, oh boy, there we go. So this is going to be 3 f of x minus x, which is equal to the, no more limit. I'm going to do a direct substitution here because I don't think I need the limit. So I'm going to do 3 f of 3 minus 3. What is f of 3? f of 3 is 1, so it's 3 times 1 minus 3, which is 0. If I'm looking at the denominator now, it's the same thing as 3 squared minus 4 times 3 plus 3, which is also 0. So now I can use the L'Hopital's rule. I call it LHOP. Put an LH here. All we're going to do now is just take the derivative of just the numerator. This is not quotient rule. The derivative of the numerator would just be 3f prime of x minus 1 all over 2x minus 4. So do the derivative of the top, the derivative of the bottom, and I believe I can do a direct plug-in now. F prime of 1, take note of that, is equal to 3, because that's the slope of this, which is rise 1 over 1. So this is equal to 3 minus 1 all over 6 minus 4, which is going to give me a 2 over 2. So this answer here is going to equal 1. So they'll usually throw an LHOP in there out of nowhere. So it's super common. Everything you've seen right now is super common. Candidates test is probably the most common of all these types of questions. LHOP has been there a couple times. Let's keep on moving on here. For our next problem here, again, same prompt. For part E, we have h. It's a whole new function here. H is being defined by h equals g of x minus x. On what intervals, if any, is h increasing for the interval from 0 to 5? Show the analysis that leads to your answer. So we're trying to see if h is increasing. If something is increasing, that's rate of change. We define the rate of change of h. In order to find the rate of change of h, we need to take the derivative of h. Let's go ahead and do that right now. So h prime of x is equal to the derivative of g is g prime of x minus 1. Now, if you remember, we solved for g prime earlier. G prime we know is just f of x. So this is the same thing as f of x minus 1. So if we're trying to see when this is increasing, we need to find out when h prime is 0, and we'll make a sign chart and see what's going on from there. So we need to set h prime of x equal to 0. That means f of x minus 1 is equal to 0. To solve for that, when does f of x equal 1? That's going to happen at, you can see it right here, happens at x equals 3 and 4.5. And I know that's 4.5 because it's line. So, I mean, you can just look at it and tell it's 1.5. But mathematically speaking here, this has a slope of -2 because it's a line. So you can just go down 1 unit and over a half unit. So this is going to happen at x equals 3 and 4.5. So now I'm going to have a sign chart from 0 to 5, and I have critical points here of 3 and 4.5. So when is this f of x minus 1? So between 0 and 3, if I have f of x minus 1, think of it this way. It's as if you're taking this entire graph right here, and we're moving it all down 1 unit. So I'm going to look at this right here. And below this dotted line is going to be where h prime is negative. So this top part represents h prime. So we're negative from 0 to 3. We're going to be positive between 3 and 4.5, and we're going to be negative from 4.5 to 5. That means that h itself is below is going to be decreasing, increasing, decreasing. So h is increasing I include these. Your teachers might not include these, but technically we do increase on the intervals. Not a big deal if you're wondering, oh my gosh, what do I put for the AP exam? AP graders do not grade your endpoints, so it doesn't matter which one you do. Maybe they'll probably even say on what open intervals, just to take that whole thing away. But anyway, so h is increasing on that because h prime of x is positive. Okay, let's go ahead and find the average rate of change of g on the interval from 0 to 5. Let's do that real quick, and then we'll answer the second part. So average rate of change of g is going to be g of 5 minus g of 0 all over 5 minus 0. Now earlier I did find all these values. I have g of 5, which right here is 3, and I have g of 0, which is pi. So I have 3 minus pi all over 5. Okay, so this is my average rate of change. Please write this stuff out, because I don't know if your AP grader knows what ROC is. That is not a joke. They might not know. So just put average rate of change. Label it. Now, does the mean value theorem guarantee for which the g prime of c is equal to the average rate of change? So this is just asking, does MVT apply? So MVT says two things. It says that function is continuous, so is g is continuous on 0 to 5. Should we include those? Not a big deal, because it says that we just want the interior of this anyway. So is g continuous? That's the first question. And then we need to know, is g prime continuous? Which is the same thing as saying, is g differentiable? So g prime is continuous. Continuous. Because g is differentiable. So essentially, if g prime is continuous, that's really saying f is continuous, because don't forget that g prime is equal to f on this interval from 0 to 5. Okay, so first off, is g continuous? G is just an integral defined function, and it is going to be continuous as we go through here. Nothing weird going on. And then is g prime continuous? In other words, is f continuous? F is certainly continuous. So does the MVT apply to equal this rate of change? Yes. Because g is continuous on 0 to 5. Ooh, that's terrible handwriting. I'm sorry, I gotta put up with this. Put it right here from 0 to 5. And g is differentiable. It's the same thing as saying g prime is continuous. G is differentiable in 0 to 5. All right. Moving on down here, this is a BC only question. So same prompt, everything here. Evaluate this integral right here. So when I look at this integral right here, this looks like integration by parts to me. And the reason it looks like integration by parts is because we have a function times a function, and that's going to be integration by parts. So I'm going to do the tabular method here. We need to figure out what u is and what dv is. So u is something that I can take the derivative of, and dv is something I take the integral of. And I can take the integral of both of these, but taking the derivative of f is probably more difficult to do, because we get up to f double prime, f triple prime, which I don't really know those values of that because I just have the graph of f. But I can integrate it. So let's go ahead and let u be x plus 2, and let's have dv be f prime of x. Okay, so that's my plus, and then so I'm going to take the derivative of my u. I'm going to get just a 1, and then the integral of f prime is just f of x. So if I can rewrite this integral of x plus 2, I'm going to ignore the bounds for right now. F prime of x dx is equivalent to, if I were to, I'm going to use a highlighter function here. Highlight in green. It's going to be this first part. So that's going to be x plus 2 f of x minus, I'm going to highlight the next part, orange. Now since I'm doing the orange across, that means I need to do the integral there of f of x. So this is going to be minus 1 times f of x, which is just f of x, dx. So this is what integration by parts gets us. And then we have the integral of f of x, don't we? We can find that value very easily by plugging in values. So here we go. So now let's put this now in our problem with our bounds. So we can say that this right here is the same thing as x plus 2 times f of x with bounds from 2 to 4 minus the integral from 2 to 4 of f of x dx. And substituting in, I'm going to keep this graph over here to the left so that you can see that. So plugging these values in, I'm going to get 4 plus 2, which is going to be 6 f of 4 minus 4 f of 2 minus the area from 2 to 4 here of f of x is clearly 2. So this part right here underlined is 2. Okay, so what is that going to get me here? That's going to give me 6 f of 4. F of 4 is 2, so it's going to be 12. Minus f of 2 is 0, so it's 4 times 0. Minus 2, so I'm going to end up with an answer here of 10. And again, we did this by using integration by parts. I think tabular method is the way to go. And that's going to wrap up our whole video here. This is a bunch of different stuff that you can see on the AP exam. Do not forget to like and subscribe.